This is the short version of practice problem number 1 from lesson 7, no bending or stretching, and unit 1, rigid transformations and congruence. And rigid means that the shape cannot be bent or stretched. The angles have to remain the same size. The length of the sides have to remain the same. It is not flexible. It cannot be changed. The shape is rigid. It can only be slid across the plane or the coordinate grid. It can be flipped, it can be rotated, but it cannot be stretched and it cannot be bent. It is not flexible. It is rigid. Problem number 1 asks, is there a rigid transformation taking rhombus P to its image rhombus Q? And explain how you know. So can I move P in some way, flipping, rotating, sliding, so that it exactly covers rhombus Q? So here is rhombus P, here is rhombus Q. So in some way, if you trace rhombus P or trace the angle here, copy it, measure it with a protractor, and compare it to the angles in rhombus Q, you're going to find that there is a change in size, so there is not a rigid transformation. So if you look at this angle here, it is smaller, it's less than 90 degrees, and this angle is the same size compared to these two angles, which are greater than 90 degrees. So if you look at the smaller angle in P, and this is the smaller angle in Q, it's less than 90 degrees, same size as this angle up here, but this angle is greater than 90 degrees, and also this angle is greater than 90 degrees. So if you compare the two smaller angles of each rhombus, you're going to see that those angles are different sizes. If I slide this rhombus over right on top of rhombus Q, this angle is smaller than the angle in rhombus Q. If I rotate it up, so notice the sides are the same length. This side is the same length as rhombus Q. This side is the same length as rhombus Q, but the angles are a different size. Therefore, it is not a rigid transformation. It's been stretched out a little bit. It's been made smaller, made larger compared to each other. It's not the same size. It is not a rigid transformation.